We start with the horizontal.
Always.
Angle of elevation is the angle between the horizontal and the object, would you say, or the...
Yeah, and it goes up from the horizontal.
Right? You're going to elevate. If you think about that, you go on an elevator, you go up, right? Now, the angle of depression is also measured from the horizontal, and that goes down. So if you're depressed, you're really down, okay? So the best thing to do right now is to just take a look at an example problem.
Yeah. Okay, so we've got Sarah measures an angle of elevation to the top of a tree as 23.5 from a point which is 250 meters from its base. Her eye level, where the angle measurement was taken, is 1 meter off the ground. Assuming the ground to be horizontal, find the height of the tree. Okay, so we need a Sarah.
Let's set up, draw. There's Sarah. What else do we have? We have a tree.
Oh, it didn't switch color.
That's okay. What else do we know? We can do what you know in different colors. So
okay.
We know that angle of elevation to the top of the tree is 23.6. But
from where she's looking.
Yeah, we got to be careful. From her eye, right?
Yeah,
so it's from her eye to there is...
And since we hear angle of elevation, we're just going to draw a horizontal line.
That's kind of horizontal.
Not beautifully horizontal. Okay, well here.
23.6?
Yeah.
Good. There's our right angle. And we also know that she is, or her eye level is 250 meters from the tree. Mm-hmm. And her eye level is 1.5 meters above the ground. Mm-hmm. You want to make sure always that you have the same units, so it's okay. We have meters.
Yeah, true that.
True that. Okay, so now we can use what we learned yesterday, SOHCAHTOA.
Yeah, but we need a triangle. So what we're going to do, and this is tricky because it looks like there's a lot of information, we're just going to ignore this 1.5 for now, but we can say if this is 250, we can say that this is also 250, right? So, and that allows us to then work with this triangle.
Right.
Okay, and then we're going to find the height.
The height of the tree, right.
There we go.
So first thing we do, label our sides.
Label our sides.
Opposite, across from our reference angle, adjacent.
And then that's the
hypotenuse. So the two things that we're working with here are adjacent and opposite. Mm-hmm. So what do we want?
Opposite and adjacent. I think
TOA. Tangent.
Okay, now always tangent of what?
23.6.
Tangent of the reference angle. And we have x.
Over 250.
Mm-hmm.
So we're going to solve for x, multiply both sides by 250, and use our calculator. 250 times tangent 23.6. Boom. 109.
Mm-hmm.
So we know now that our distance x is 109, but are we done with the problem?
No. And this is very, very much not to scale. But what we did find is we found that this is now 109. And I'm keeping a couple of decimal places just because I'm not done with the problem, okay? So that was our first step. And our second step is that, remember, we need the height of the whole tree. So we also need this. Now this is Sarah's height.
1.5.
So we need to add that on. So 109 plus 1.5. And there we go. So it's 110.7. And I'm just going to round it to 3 significant figures to be 111 meters. Done.
3 significant figures.
Messy,
Next problem.
but
Messy.
Horrible, actually. Sorry, guys.
From a vertical cliff, 80 meters above sea level, a fishing boat is observed at an angle of depression. Now we're going down. Mm-hmm. Depression of 6 degrees. How far out to sea is the boat? So that's the horizontal. You can see the 6 degrees there.
And there's the depressed, right? The depression going down. Mm-hmm. Now it's 80 meters above. And we need to basically figure out how far out to the sea is the boat. There's the boat.
There's the boat. So there's our x.
Yep.
Okay, so do you want to do it now with...
Yeah. So maybe we'll go and look at this for a second. So pause this. We're going to come back to it in a second, but there's something that that we wanted to bring up that is always helpful. So if you have an angle of elevation, right?
Yeah.
Of A to B, and then the angle of depression is also theta. So it's interesting because what they're saying is that this and this is the same. Now you might remember, and the way I drew it might already conjure up a memory. Do you remember learning the parallel line theorems, right?
Right.
And you may remember learning that when you have a Z like that, then these angles are equal.
Alternate interior angles,
Alternate
I think it's called.
interior, fancy.
Good, huh?
Nice.
So we can do the same thing when we have angle depression problems. If you look at the 6 degrees in the problem above and draw that Z, that angle right there is also 6 degrees.
And the reason that we want to do that is because this right now is outside of the triangle that we're working with, as opposed to if we put it on the here, now all we have is just a very straightforward triangle to work with.
Okay.
All right, Ms. Borbe, we got to label our sides.
Opposite, adjacent. Again, we're going to be working with tangent.
OA, tangent, perfect.
So tangent of 6 degrees is equal to 80 over x.
Okay, now here there's a little bit of algebra involved, right? Because the x is on the bottom. So this sometimes the kids find more difficult to get it out of the bottom, right?
Right.
So what I'm going to do is I don't like it on the bottom, so I'm still going to multiply both sides by x. And what we've got now is we've got x, tangent 6 is 80.
And let's get x by itself, isolate it. We have x is equal to, divide by tangent 6.
Now tan 6, it's just a number, right? It's just like if you had 2x being 80, you'd divide by 2.
Right.
Okay, so kind of one more step.
80 divided by tan 6.
Okay.
761 to 3 significant figures. And the last thing you want to do is, does that make sense?
Exactly.
We've got an 80-meter cliff. I think so, right?
Yeah, that makes
Pretty
sense.
small angle.
Yep. Really small angle, so you're going to have, make sense for the boat to be 760 meters out. If you're getting 0.3 meters, not going to happen.
Okay, next one. Let's look at one more problem.
You want to do that
Yeah,
one?
let's do it.
Okay.
From a point A, 30 meters above the base of a building B, the angle of elevation to the top of the building is 56, and to the top of the flagpole is 60. So this is a kind of problem like the first one, only it's set up now with 2 different angles.
Yeah, and it just wants the pole, the flag. Okay, well, I don't know, hopefully you guys can see, but this has, we're going to need...
We have 2 triangles in
Two
here,
triangles,
right?
exactly.
So we have one triangle with 56 degrees, and that's to the building, and we have one of 60 all the way to the top of the flagpole. So if we actually find that side length for both of those triangles, we can subtract it, right?
Perfect.
That's our strategy.
I like the way you sang.
Okay, so let's set it up. First, we have what sides? We have opposite for both of those. We have a small triangle, and we also have the adjacent for both of those, right?
So this is the adjacent.
That's the adjacent.
That's the hypotenuse. We don't know it and we don't care to know it. So
We don't need it because we're going to be dealing
And then
now
that's the
with
opposite.
tangent. So let's,
So
small
OA.
triangle has 56 degrees. Tangent of 56 is equal to x over 30. And the big triangle, large, okay, is equal to tangent 60. And now we have y over 30.
Okay.
And what we want to do in the end here is subtract y minus x. So let's solve for x first.
And guys, remember, you can pause it and try and finish the problem on your own and then see if you arrive at the answer.
So 30 tangent 56, we get out our calculator again.
So you can probably tell that coming to class without a calculator in this unit is going to be very hurtful.
And we don't want to round here, right? We want to carry at least, how many should we say?
I think 3 sig figs.
3 sig figs.
Oh, I
No,
mean
no.
3 decimals?
3 decimals?
Yeah.
And then you round at the end. That's always should be your strategy for these kind of problems. So y is approximately equal here to 30 tangent 60. 51.962.
And of course, I like that my height for the larger triangle is a bit larger.
Good. Now we know that y minus x is going to give us just the height of the flagpole.
How is this for a mathematical equation?
Very nice. So our y was what? 51.9615 minus 44.476. 7.49, and this is where we're going to do the rounding to three significant figures. What was our units? Meters. Does that make sense?
7-meter flag on top of a building, sure thing. Yeah.
Okay.
That seems reasonable.
Good. Thanks.
So there you go. That's angles of elevation and depression.